In this video, we are going to see how we can find the inverse of a square matrix. Now let's start from the easiest idea first. For example, you have a simple number, not a matrix, let A be a number. The meaning of inverse, or more precisely called multiplicative inverse. Okay, multiplicative inverse. So it's talking about a number called A inverse, and then multiply to A, which is equal to 1. But 1, we are talking about the identity, because there won't be any 1 when we are talking about square matrix. So for example, like if you have a 2, then 1 over 2 is the inverse, because 1 over 2 times 2 is equal to 1. For example, you have minus 1 over 3, and then as a result, minus 3 will be its multiplicative inverse, because after multiplying the two numbers, it will be equal to 1. Indeed, you will also find that actually it's about the index law, because the inverse of 2 means that it's 2 to the power minus 1, which is 1 over 2. Minus 3, you will see that it's minus 1 over 3 to the power minus 1 as well. So we will extend this idea to the inverse of square matrix afterward. Next, we come to see the meaning of inverse of square matrix. For example, we have a matrix A, which is called 2, 1, 3, 2. Now, if you use the idea of inverse of a number, then it's like A inverse, right? But if you consider it as 1 over A, that means 1 over 2, 1, 3, 2. But if you still remember, division of matrix is undefined. So that's why the idea of this one is not valid, or is not okay. So afterward, that means we have to seek for a matrix called A inverse, in which after it's multiplied to A, it will be equal to 1. That means our identity matrix. Because now the matrix of A is of odd 2, or you can say 2 by 2. That's why the identity, or the 1 matrix, now we are considering should be called 1, 0, 0, 1. Now we are seeking for what is the A inverse. So on the other hand, you should also notice that actually when we swap the order of multiplication, now it comes to A times A inverse. So it should be equal to identity matrix as well. So now I give you a matrix called B. You'll see how you can prove that it is equal to the A inverse. It is 2 minus 1 minus 3, 2. And now we are going to check for the following. So it would be AB or BA maybe. Okay, so let's check for BA. BA will be equal to 2 minus 1 minus 3, 2, and then 2, 1, 3, 2. Now you have to apply the multiplication rule of matrix. 2 minus 1 multiplied to 2, 3, as well as 2 minus 1 multiplied to 1, 2, followed by minus 3, 2 multiplied to 2, 3, followed by minus 3, 2 multiplied to 1, 2. And now you can pause the video for half a minute and try to get the answer. So it should be 4 minus 3, that means it's 1. It's 2 minus 2, which is a 0. Minus 6 plus 6, which is a 0 as well. And minus 3 plus 4, which is a 1, which is your identity matrix. So that's why you will see that, what's the meaning of inverse? Now, it may not be totally related to 2, 1, 3, 2, as indicated in the matrix A, but it can be totally different, you will see. So that's why we will say B will be A inverse in this case. There's another question of finding the inverse of A, which is quite abstract. For example, like now I told you, is given information that A squared plus 3A minus I is equal to 0. Now you are asked to find the A inverse. So it will be very hard, because you don't know what is A, as well as I'm not giving you a B like in the previous example. But yet, if you follow the idea of A inverse means it should be a matrix in which after multiplying to A, which is equal to I. So that's why I noticed that in the sentence or in the equation, there's an I over there. It will be the start on how we can solve the problem. So at first, I'm going to see A squared plus 3A equal to I. So I start with, I need to have an identity matrix first on one side, for example, on the right. Next, we come to see how I can find A as the common factor. Then next you multiply to something, which gives you I. Now the question you will see that it reduced to a very simple question of taking out common factor, at which you will see a plus 3. But be careful that 3 is a number, while a is a matrix. They can't be added up together, right? So that's why when you have a single 3 over there, do remember that it's like 3i. That means it's a matrix. After you're taking away the a from 3a, so the outcome should be 3003 left behind in the equation. So which means it's a 3i. So as a result, you will see that a multiplied to a certain thing, which is equal to identity matrix. So it's totally following the idea or the definition of inverse. So as a result, we will say E inverse will be equal to a plus 3i, even though we know nothing about the a. Whether the size is order 2, order 3, or what are the numbers in the a, it doesn't matter. The next section of this video will be how we can find the inverse by ourselves. It will be a very, very tough job because we have several things and a very massive calculation going to see. So, but before we can find out the inverse by ourselves, there are some terms you have to know first. And first of all, will be it's called transpose of a matrix. So the notation will be called AT, or sometimes you can see some textbook will be AT. So it's not talking about the power, but it's like about symmetry or reflection. And for example, like we try to have a rectangular shaped matrix first. For example, you have 1, 2, 3, 4, 5, 6. So the meaning of transpose would be, so you are going to turn the first row into first column. So that means now 1, 2, 3. Okay, let's wait. 1, 2, 3 will be vertical. Similarly, now your first column will becomes second row will become the second column, which is now is 4, 5, 6 in this way. So this is the meaning of transpose. That means you are turning the row into the column accordingly. Now you can see in square matrix, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9. After you take the transpose of it, that means you're going to turn the row into column accordingly. First row become first column, second row, second column, and lastly, third row, third column. So that means the numbers now will become 1, 2, 3, vertically arranged, 4, 5, 6, and 7, 8, 9. So this is the meaning of transpose. The other way around would be, I find some students or some people would like to look at, actually transpose is a kind of reflection. So what does that mean? So that means it's like, okay, so let's take another color. Also, according to the diagonal, that means according to 159, so first of all, the numbers should be remains unchanged over there. So that means 159 will be remained along the diagonal. So afterward, then, so 4, 2 will be symmetrically reflected. So 2, 4 here in this way. 7, 3 at the corner becomes 3, 7. So at last, 8, 6, swap the position. So you also get the transpose. So let's see which one in which way you would like to remember the idea of transpose. You may use this way, row becomes column, or vice versa. Or you can look at the reflection about the matrix when you talk about transpose. After noticing or understanding the idea of transpose, hopefully it will be a very easy job to you. Then it comes to the other term, which is called adjoint of matrix A. To start with, let's see whether you still remember there is a sign belongs to each position of a matrix, which is coming up from positive, then alternatively change to negative, positive, positive, should be negative, positive, negative, positive, negative, positive. So if you still remember it, then it will be used to find the adjoint of matrix A as follows. It will be a very tough job, and let's start with a square matrix of order 2. For example, 1, 2, 3, 4. Now, in order to find the adjoint, it will be a very big task because, so first of all, it consists of things which is about transpose. So that's why there are 2 steps in order to get it. The second step is very critical and difficult because in order to find the adjoint of matrix, it will be like what we are doing in cofactor. So what does that mean? For example, if I want to find the new value of 1, 1 here. Then we cross out the row, cross out the column, and you get a 4. So this 4, according to the sign, is positive. So that's why the outcome now would be 4 here. So let's see whether you can follow it. Hopefully, yes. Then next, we come to the second part. So in order to get the next position, which is called A12, now we look at 2. Cross out the row, cross out the column. You have a 3 left behind over there. But in this position, it's negative. So which means the number now it should be minus 3 here. So let's pause for a minute and see whether you can obtain the last 2 values, which I am going to do it in green, as well as what color I can use. Okay, maybe purple. Please pause the video and try to do it. Okay, coming up next, we look at the A21 position. So the situation would be cross out the row, cross out the column, and you have a 2 left behind, and the sign which is a minus. So that's why the outcome should be a minus 2 here. While the purple one, I cross out the row, cross out the column, which is a 1. The sign is positive, so they will be fine. So at last, according to transpose, then now you can write down the answer. So row 4 minus 3 will become vertical. Second row minus 2, 1 will become the second column minus 2, 1. So this is called the adjoint of A in a matrix of order 2. The case of order 2 matrix is not very hard, right? So you basically can obtain the rule, and then so you get the result of adjoint of A. But now when we come to order 3, it's a disaster because the first step is extremely extraordinary very big. So that's why I like to put a big brackets. So when I'm doing it in test paper or in exam paper, then normally I will use like 6 lines or 7 lines or 8 lines and leave yourself some space. So the outcome, of course, is simple. Okay, so now let's see how we're going to do it. Okay, so the way will be still the same. But because now it's too big, then I will write down the negative sign first into the table. Because it helps to remind me that I need not to check every time. So minus, 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 minus. So what does that mean? Now we come to have the red one. Well, if you consider the first number, so in red, so you look at 1 here, right? So then you cross out the row, cross out the column. So now I have 4 numbers left behind. So how I can put it in my new matrix? To your surprise, it will be 5 minus 1, 1, 2. So that means the first number, you have to find the determinant of crossing row, crossing column, and you've got 5 minus 1, 1, 2 over there. So this is the first number, A11 in your new matrix. So if you can't understand it quite well, so now let's start from the next one, purple. So I suggest you put the negative sign first because it's very easy to overlook it. So in order to look at the numbers, we look at the 0, right? Cross out row, cross out column. You have minus 2, 3, and minus 1, 2 over there. So these are the 4 numbers you need to put in your new matrix. Now I put the answer. It's minus 2, minus 1, 3, and 2. So if you basically understand the idea, now please stop the video and try the work by yourselves. Alright, so I suppose you spend like 2 or 3 minutes time to work on it. Very hard, right? So now I just briefly write down the answer and see whether you got the proper answer or not. At the same time, you can also check whether I make careless mistake. So you understand why I at first put the negative sign first in yellow, because it's very, very easy to make a mistake. Okay, so basically it will be like this. So afterward, in each determinant, then now you're going to do the calculation. So you remember 5, 2, it should be positive in direction, while 1 minus 1, it is in negative direction, and so you add up the numbers afterward. So as a result, I do the mental by myself. So it's 11. Okay, so at last it will be the adjoint of A. And you will see once it goes to 3 by 3 matrix, it's not kidding. And so it's a very, very massive calculation over there. So if you continue to talk about order 4, order 5, then you will see it will be a disaster, right? Okay, so finally we come to our main target. We are going to find the inverse of A. Now you will see the definition will be quite terrible because it consists of 2 parts. The first part would be a number, which is a 1 over determinant of A. That means you need to find the determinant. So please note that it's just a number. So it's like, yes, it's a number here. So while the second part will be adjoint of A. So you remember the very, very big task we just completed a minute ago. So after combining them together, so it will be the A inverse. Now we take a look on 2 examples. One will be simpler, about 2 by 2 matrix, while the other one will be very massive work once again, so which is a 3 by 3 matrix. Now let's start from 2 by 2 matrix. Like now the matrix A is called minus 3, 2, minus 2, 2. To start with the question, normally I will start from finding determinant because it's easiest. Then you multiply the numbers in this direction, add up, minus the numbers in this direction, in this direction. So that means it's minus 6 minus negative 4, which gives you negative 2. So that's the first step. Second step will be quite big because of adjoint of A. I first need the table for reference, right? Well, I need plus, minus, plus. So that's why adjoint of A will be equal to, besides putting the negative sign, I would like write down the transpose as well. Because these are the 2 elements I missed out very easily. So coming up next, I have to cross out row and column, so which gives you a 2 for the first number. Okay, row and column cross out, so which gives you negative 2 here. And of course, at last it goes to a 2. Cross out row and column, you have a 2. Cross out row and column, you have a minus 3. Do slowly, don't touch the transpose, except you're a very careful person. So here is the outcome here. And finally, you've got change the row into column, change the row into column as well. Minus 2 or minus 3. So this is called adjoint of A. So if you like, you can say it is kind of like step 1, step 2 to find the adjoint. And coming up next, step 3, you're going to combine the numbers. A inverse will be 1 over determinant that you will see is a number only, right? Multiply to a matrix, which is adjoint of A. And the result now, I've got 2 minus 2, 2 minus 3. Now, finally, you will see that this 2, the division of 2 cannot cancel all the numbers in the matrix because there's a 3 over there. So I would say you may just pause it here as the answer, but a little change will be, we rarely put minus sign at the bottom, but we put it on top. So that's why you can leave it as the answer. Or if you like, you can move in the minus 1 over 2 into every element in the matrix. But of course, it takes you some time to do calculation, so which is equal to minus 1, 1, minus 1, and this one is not good, so which is 3 over 2. So both answers are accepted. But the basic principle is only if the number outside can cancel every element in the matrix, then you need to do, you are compulsory, you are requested to do so. Or else both answers will be accepted. either the number outside or you multiply the number into every element. At last, we come to our hardest job on finding the inverse of order 3 matrix. So this time I use an letter B, so capital letter B, to be the matrix, the name of the matrix. So we follow the same way. First of all, we find determinant. So you will see it won't be a good job already, because now if you multiply in this way, then it also takes you quite some time, right? And also next you may need to copy the numbers there, 2, 3, 1, 1, 5, 2, right? Then you multiply the numbers, multiply the numbers, multiply the numbers. Positive direction and negative direction in another way. So I do the work by myself. So it would be 2, 5, 2, 4, 5, 20, 1, 2, 1, so which is a 2. 2, 3, 2, which is a 12. Minus 1, 5, 2 is a 10. 2, 2, 2 is a 8. 2, 3, 1 is a 6. I better use a calculator just in case I carelessly make a mistake. Right? But I get the answer already while I'm taking a calculator. Okay, which is a 10. Now, if necessary, you pause the video and then do the work yourselves. Don't just copy my work. Well, the next job would be very, very big, you remember, so which is called adjoint of B. So make sure that you give yourself enough space to write the very, very big matrix, as well as you may need to draw the table for your reference, or you just directly write down in this way. But this is also one of my habits on working on the adjoints of a 3 by 3 matrix. Then you can fill in the numbers directly over there. But once again, you pause the video and you write down the numbers by yourselves. All right, so now we check the answer. So it should be 5, 2, 2, 2, 3, 1, 2, 2. So this is adjoint of B. Finally, you can say B inverse will be equal to 1 over 10 of the following matrix. But this time you will see it's better not to multiply the numbers inside, because it takes you quite a long time to rewrite the answer finally, right? But you just leave 1 over 10 outside as the answer this time. Also, this is the rules or demonstration on how to find the inverse of a matrix. It's hard, it's difficult to remember. So that's why you need to do some exercise until you can remember the rules. Let's work hard. See you. Bye-bye.